In number 1, are the triangles shown below similar? Present an informal argument as to why they are or are not similar. We have angle A is 31 degrees, and angle A prime is also 31 degrees. Angle B is 103, and angle B prime is 103. So yes, triangle ABC is similar to triangle A prime, B prime, C prime because there are two sets of corresponding means matching up, A with A prime, B with B prime, angles that are equal in measure. And we call this AA criterion. This is going to be a key phrase for when we get down the road into some later lessons. Number 2, angle A is 64 and angle A prime is 64. Angle B is 84. Angle B prime we don't know. Angle C we aren't sure about, but angle C prime is 32. We need to solve for one of those missing angles to determine if two of them match up. We already have one, but we need to determine one of those missing angles to figure out the other. So if I add 64 and 32 together, that gives me 96. To get to 180, I need to figure out what that missing piece is. 10 minus 6 is 4. 7 minus 9 I can't do, but 17 minus 9 is 8. So B prime must be 84, which gives me that second set of angles that are equal in measure. So for number 2, yes, triangle ABC is similar to triangle A prime, B prime, C prime because we have two sets of corresponding angles that are equal in measure. Again, this is called AA criterion. In this one, angle A is 99, angle B I'm not sure about, and angle C is 37. I am going to solve for angle B by figuring out what piece is missing from 180. So 180 minus 136 is 44. And in the second triangle, angle A prime I'm not given. Angle B prime, they tell me, is 43. And angle C prime, they don't tell me. So I don't even have one set of angles that are the same. No, these are not similar because there are no sets of angles that are equal. In number 4, are these similar? Angle A is 31. Angle B, I'm not sure about. Angle C is 46. In the other triangle, angle A prime is 31. Angle B prime, I don't know. And angle C prime is 46. I have 2 sets of angles that are equal in measure. So we will say, yes, triangle ABC is similar to triangle A prime, B prime, C prime, because we have 2 sets of corresponding angles that are equal in measure. These meet the AA criterion, the angle requirements. Number 5, angle A is 70, angle B is not given, and angle C is 29. A prime is 70, B prime is 81, and angle C prime is not given. For these, to figure out this missing angle down here, 70 plus 81 makes 151. And to get all the way to all the angles we need, we can subtract that from 180, which gives us 29 for angle C prime. This means there's 1 set and 2 sets. So yes, ABC is similar to A prime, B prime, C prime. And the reason is the same as the previous ones. Number 6, angle A is 27, angle B is 31, and angle C is not given. In A prime, it is 31 degrees, B prime is 103 degrees, and we need to figure out, is that enough to tell if they are similar or not? Well, none of these angles match up, and even if we had one that matched up, we need 2 because it's AA criterion. We need 2 sets of angles. So even if the third worked, it wouldn't be enough. No, these are not similar. There are no sets of angles that are equal in measure. Angle A is 25, angle B is not given, angle C is 53. A prime is 25, B prime is 102, and C prime is not given. If we add 102 and 25 together, we get 127. Then we need to take that away from 180 to figure out what that missing piece is. 10 minus 7 is 3. 7 minus 2 is 5. So C prime must be 53, which means they are similar, and our reasoning is going to be the same.